Assalamualaikum warahmatullahi wabarakatuh. Hello and welcome. We are from the ANVARSY. Our member consists of Devaro Brahmansyah, Diva Ahmad, me, Muhammad Brilian, and Resi Surya. And we are going to present the progress of our project for artificial intelligence final exam. And this is our third report. Next. In the first week, we have carried out about the problem background and the methodology. In the second week, we carried out data set that we use and the design of the chatbot that we are going to make. And now we are going to discuss about the code and the training of the model. Next. The first part of creating the coding is creating the training data. Next. The data is collected from more than 6 different sources on the internet, including telkomsel.com and smartfriend.com. We managed to create a corpus with over 1,700 words before pre-processing and around 366 words after pre-processing, which you can see on the picture below. Next. Creating necessary functions. Next. Function to import the JSON file. This function will open the instance file, then a variable called dataset is created, then its value is set to every single data that exists in the file. Then the function returns dataset. Next. Tokenizing function. The purpose of this function is to tokenize the words in the dataset and organize them into different lists or say variables, which are words, intent text, intent X, and intent Y. Words are just every word that the function found in the file in the intents JSON. Intent X is the user input aka pattern and the response as well from the JSON file. Intent Y is the tag of each pattern and the tag is the tag. Finally, the function returns word, intents X, intents Y, and intents tag and intent tags. Next. Stemming function. This function is to convert every word into its root words. First, it creates an empty list, then every word is stemmed using the NLTK library, which is Manchester Stemmer, and then it is saved into the list. Then the list is sorted and duplicates are removed. Finally, it returns the root words. Next. Function to convert dataset into numerical data. Now, this function is a little bit more complicated, so I will explain it a little deeper about how the function works. The purpose of this function is to convert the training data into a format suitable for training a machine learning model, which is binaries. The breakdown of what the code does. First, it initializes a stammer object from the NLTK library. Then it creates two empty lists, training and output. These lists will be used to store the process training data and corresponding output labels. The code then iterates over the intent X list, which contains the tokenized input patterns. For each input pattern, a new list called bag of word is created. This list will represent the presence or absence of each word from root words in the input pattern. Within the inner loop, the code converts each word in intent X to lowercase using the lower method. Then it applies stemming and appends the stemmed word into the words TMP list. For each word in root words, the code checks if it's present in words TMP. If the word is found, it assigns 1 to found, otherwise it assigns 0. The value found is then appended to the back of word list. Once all the words in the root words have been processed for a particular input pattern, the back of word list representing that pattern is appended to the training list. The code then prepares the output labels for each input pattern. It creates a list called output row with all elements initially set to 0. It then sets the element at the index corresponding to the intent tag of the current pattern in instance y to 1. The output row list is appended to the output list. After processing all the input patterns, the code converts the training and output lists into numpy arrays using the numpy.array function. Finally, the function returns a tuple containing train x and train y arrays. Next, Diva.
And next function to train and build the model. Dev build model. The code defines a function called build model that constructs and trains a neural network model using the provided training data. It sets the number of inputs to 500 and the batch size is 16. It initializes a sequential model using df.sequential. It adds a dense, fully connected layer the model with batch-sized neurons as the input layer. The input step is set to the length of the feature vector. It adds two more dense layers to the model, each with batch-sized neurons. These are the hidden layer of the neural network. It adds a dense layer to the model as the output layer with the number of neurons equal to the length of the output labels. The activation function for this layer is set to softmax, which is commonly used for multi-class classification problem. It compiles the model using the Adam optimizer, categorical cross entropy as the loss function, and accuracy as the evaluation metric. It trains the models using the fit function. The prof- it provides the training data train X and train Y, the number of epochs, batch size, and sets for both to 0 to suppress training progress output. It prints a summary of the model, which provides information about the model architecture and the number of parameters. It evaluates the accuracy of the trained model by applying it to the training data and obtaining the test loss and test accuracy using evaluate function. Finally, it returns the trained model. Next, and this is the function to load the model. Dev prepare model. The code provide defines a function called prepare model that takes a dataset and optional model file as input. The purpose of the function is to prepare a chatbot model or training or interface. It calls the tokenize word function to tokenize the words in the dataset and obtain words instance X, instance Y, and instance tag. It calls the stemming function to perform stemming on the words list and obtain root words. It checks if a file or directory with the name specified by model file already exists. If a file or directory exists, it loads the existing model using tf keras models load models and assign it to the model variable. A message indicating the successful loading of the model prints. If the file or directory does not exist, it processes to create a new model. It calls the getTrainingData function with root words intent X, intent Y, and intent tag as input to obtain the training data train X and train Y. It calls the build model function with train X and train Y as input to create a new model. The newly created model is saved to this file specified by model file using model save. The function returns a tuple containing the model's root words and intent text. Next, this is the chat function. The code defines a function called chat that allows for interactive communication with the chatbot. It takes the chatbot model, root words, intent text, and dataset mesh or user message as input. It enters a loop to interact with the chatbot until the users enter quit. Inside the loop, it tokenizes the user's message using regular expression and stores the token in the tokens list. It applies stemming to each token, use the Lancaster stemmer algorithm from NLTK and stores the stemmer token in the token TMP. It creates a bag of words representation for the token by checking the presence or absence of each root word in the token's TMP list. The results are stored in the bag of words. It uses the provides model to predict the intent tag for the bag of word representation. Probabilities for each tag are obtained using model predict. It finds the index of the intent tag with the highest probability using NumPy argmax. It checks the confidence level max probability of the predicted tag. If it is below zero point 0.8, the chatbot responds with a default message indicating that it doesn't understand the user's input. If the confidence level is above zero point 0.8, it retrieves the corresponding tag, font tag, and randomly select a response from a dataset associated with the tag. The select response is returned as the chatbot reply. Next. And this is the code for build interface. The code provides a graphical user interface or GUI implementation using tkinter to create a chatbot application. First, import the necessary modules tkinter and custom kinter. Defines a function display chat message to display the message in the chat area, and then function get user input to retrieve user input from the entry data, and uh, define send message to handle the action of the send button. Create the main window using custom kinter and sets its properties such as title, size, and background color. Create a label chatbot name. ANVARSY is for the title in the interface. Creates the text area to display chat message with styling for the chatbot and user message, and creates entry area for user input, and create send button to trigger the send message function. Display a welcome message from the chatbot in the chat area. If we start to open the chatbot, the welcome message will be displayed. Runs the main window using Windows main loop to start the UI application or to display the main interface. Next. And next will be explained by Devaro.
Okay, so the next one is preparing the dataset and building the model. Okay, so for the dataset, that code suggests that there's a function called load data that loads the dataset for the chatbot. The load data function is not provided in the code you shared. However, based on the context and the usage of the dataset variable throughout the code, it can be inferred that the load data function is responsible for loading and returning the dataset used for training and inference in the chatbot. The load data function is likely implemented separately, and its specific implementation details are not available in the code snip you provide. It could involve reading data from files, querying a database, or any other method of retrieving the chatbot dataset. Uh, and then for the model root words intent text prepare model that code suggests that there is a function called prepare model which prepare the chatbot model based on the provide dataset. By calling prepare model dataset, the function is invoked and the dataset is passed an argument. So for the function performs several steps to prepare the model and returns three values: model, root words, and intent text. So for the model, this variable contains that the chatbot model that has been prepared based on the dataset. It can be used for chatbot training or inference. And then for the root words, this variable contains the root words that have been derived from the dataset. These root words are typically used for tokenization or feature extraction in the chatbot. So for the intent text, this variable contains the intent text that have been extracted from the dataset. This intent text represents the different categories or labels that the chatbot can recognize. By assigning model root words intent text, prepare model dataset, we are capturing the return values from the prepare model function into these variables for further use in our code. So, but if cannot find the one, the model will be built from scratch with the following steps. First one is tokenizing the dataset. The dataset is tokenized using the tokenized word function. And then the second for the streaming dataset, streaming step use the streaming function. The for the third is converting into binaries. The tokenized and streamed dataset is converted into binaries using the get or train data function. The resulting numerical data is ready for model training. And then number four is training and building the model. It calls the build function. The model is then saved in the local directory, and there the fifth is loading the model. So the next will be explained by my friend Resi.
Okay, thank you, Devaro. Okay, this is chatting with chatbot and result. Chat function. The first one is receiving user input. Two, performing text pre-processing like tokenizing, stemming, and converting into binaries. Three, predicting a response using the trained model based on the pre-processed input. Four, outputting a response. And there is interface function. The Tkinter library is used to generate a user-friendly window that serves as the chatbot's user interface. Users can interact with the chatbot by sending prompts and receiving response. The interface includes sections such as message from, send button, and chat area. Okay, this is the user interface for ANVARSY chatbot. Uh, there's ANVARSY and welcome message. Welcome, I'm ANVARSY, your visual customer support. And there's also message from, which we can type in here, and there is a send button. Next. Okay, for generate response, for example, we input hi there. So the system will give a output, the response, hi there, how can I help? And for another example, we type who are you? We type in message from and we click in on send button. So the system will respond, I am Anfarsi, your virtual customer service. What can I help? Okay, next. So this is use case testing. Here we input the problem of internet service provider, like my internet is slow. So the system will respond like this. I can try to help you with that and give a response about my internet is slow. And here we input it work, thanks. So the system will respond glad I could help. Next. Okay, it will respond I could help because the confidence is more than 0.8. So if we input just it work, the system will respond, sorry, I don't know what you mean. It's because the confidence is less than 0.8. And here we input tell me why fast smell bad. So the system will respond, sorry, I don't know what you mean. It's because the confidence level is less than 0.8. Next. Okay, thank you. That's all from our group. Wassalamualaikum warahmatullahi wabarakatuh.